Data centers are packing in more computing power than ever before. Between hybrid cloud setups, containerized applications, and power-hungry AI workloads, the density of modern infrastructure has outpaced the tools built to watch it. To manage this complexity, IT leaders invest in an ecosystem of specialized monitoring tools. You'll hear various acronyms, but the two primary categories are RMM, Remote Monitoring and Management, and DCIM, or Data Center Infrastructure Management. Significant capital is poured into these platforms every year. Yet, when a critical hardware failure strikes, operations teams still find themselves staring at unexplained, cascading outages. The problem is a matter of perspective. Tracking individual metrics, like a server's CPU load or a room's ambient temperature, gives the illusion of control. But monitoring isolated components is different from seeing how the entire system functions together. RMM and DCIM were built to solve different problems in isolation. Relying on them to cover the whole environment leaves a gap right in the center of IT operations. This 3D diagram shows a simplified model of the modern IT stack. It is divided into 3 vertical tiers: the base layer representing physical hardware, the middle layer for the operating system and IT operations, and the top layer for actual business services. At the base tier, DCIM watches the physical environment around your servers. It tracks cooling capacity, monitors power draw, and measures rack space. In the middle tier, RMM uses software agents installed inside the operating system to deploy patches, track active services, and issue alerts based on OS metrics. Notice how isolated the top business services tier is from the physical hardware at the base. Even more critical is the pulsing void between the base tier and the middle tier. There is no structural connection between the physical environment data at the bottom and the operating system data above it. Because these platforms occupy different operational layers, they cannot communicate. When a failure crosses from the hardware level into the software level, neither tool can see the full picture. If a specific voltage regulator on a server motherboard arcs and fails, it cuts power to that machine and takes the operating system down with it. The moment the operating system stops answering, the software agents stop working. The RMM tool loses its connection, leaving the software team blind to the cause. The DCIM platform registers the sudden power fluctuation and localized heat spike, but it has no visibility into the software. It cannot identify which specific business applications just went offline. The IT team is left to manually cross-reference dead servers with customer complaints. The root cause is buried in the hardware. The symptoms hit the business layer, and the connection between them is lost. Solving this requires out-of-band visibility, the ability to access the hardware directly through a dedicated management chip. This bypasses the main operating system entirely, allowing you to read sensors and control power even if a server is unresponsive. This diagram illustrates how Sensaka bridges the stack. Instead of isolating data in horizontal slices, a vertical bridge descends through the center, unifying all 3 tiers. At the base layer, Sensaka's DCOS component links directly to out-of-band management interfaces. It pulls real-time telemetry from the raw hardware, independent of the software running above it. That hardware data moves up into the middle tier through the IDCOS module. Here, raw thermal and power metrics are converted into actionable alerts and organized IT workflows. Finally, the Smart BSM module carries those alerts into the top tier. It maps the failing hardware at the base to the business application it supports at the top, drawing a direct line from cause to consequence. When you connect the physical environment to the business outcome, you eliminate the blind spot. Out-of-band data is the only reliable way to maintain control when an operating system crashes. Let's look at that same server failure through a unified stack. The regulator fails and the operating system dies. But instead of losing visibility, the out-of-band connection immediately identifies the precise dead component and provides secure remote access for recovery. Simultaneously, the system maps the failure to its business service. The operations team knows which customer portal is affected and can reroute traffic before the outage spreads. By linking hardware, operations, and business impact, the team works from a single operational view rather than chasing symptoms. IT teams are managing denser computing environments with fewer resources. Relying on isolated monitoring tools creates friction that slows down recovery and increases downtime. RMM provides control inside the system, and DCIM watches the facility. Both are built for essential purposes, but neither is sufficient on its own to manage modern infrastructure. Establishing an out-of-band connection is the new baseline for operational stability. To see how Sensaka bridges the gap from hardware to business services, request a trial.